Our next speaker has spent a lot of time and thought into that pesky thing called tech debt. Joining us from New Zealand, please welcome Isaac Udy, and I hope I said your last name right. Awesome. Yay. So, Isaac leads the Android team at ANZ Plus, and as a GDE for Android and a maintainer of his alternative to Android X navigation library called Enro, he is interested and knows how to scale complex systems. If you ever felt overwhelmed by tech debt, Isaac is here to give us practical, actionable ways to measure and finally manage it. Please welcome Isaac.
Hello, I've got a lapel mic, I don't need that one. Everybody can hear me down the back? Hey, awesome. Welcome to Metrics, Measurements and Migrations, how to effectively manage tech debt at scale. All right, so before we dive into the main meat of the content, I would like to ask you all to take a moment and imagine a situation with me. So, you are working on an Android project with a team, so not on your own, be that 5, 10, 20 or more other engineers. And this project has been around for a little while, so it's not brand new. But despite the fact the project has been around for a little while, you're pretty happy with the technology you're using in the project. For a little while now, you've been using Kotlin, Compose, and coroutines for all the new code you write. And so it's kind of, got its tendrils out through the code base, and you are pretty happy with this tech in your day-to-day development workflow. But waiting around the corner is a coworker with a question. Your coworker is fixing a bug or maybe working on some new functionality in an older part of the code base. And because you've been around in the team for a while, they think you might be the right person to ask for some help about understanding this older part of the code base. And they start pointing out the code that they're looking at. And when you start looking at that code, you start to realize that all of that modern tech you're using in the rest of the code base that you're using in your day-to-day development work isn't actually being used in this older part of the code base. And now, not only do you need to remind yourself how this all works, you also might need to teach your coworker how this works because perhaps they've never used Java Views or RX Java to build the application at all. So what's happened here is that the best practices, the way that you want to build your software has changed over time, and your code base hasn't quite kept pace and has created tech debt. And scale compounds this problem. If you have a larger team, you have more engineers writing more code, and the older the code base gets, the more code you have to maintain. So scale just makes this worse. And that's what we're here to talk about today. So to just reintroduce myself quickly, my name's Isaac Udy. I'm a Google developer expert for Android, and I have over 10 years of experience developing Android applications, which means I have seen best practices change, from async tasks to RX Java, and now to coroutines and beyond. And in my day-to-day job, I am the Android platform lead for ANZ Plus. And for those who are not familiar, ANZ Plus is ANZ's new sort of digital banking, mobile-first banking application. And at ANZ Plus, we have a pretty large team. So we have more than 75 Android engineers who are split into smaller teams we call squads, and we have over 20 squads working on a variety of different features and functionality. And the code base itself is also pretty big. We have over 700,000 lines of production code, and over double that if you start counting our test code as well. And that's the difficulties of scale, but we do have some sort of good things on our side. We do have a relatively young code base, which makes some of this a little bit easier. But even still, we have tech debt just like any other team. And working in such a big team and across so many squads, I've spent a lot of time thinking about how we manage tech debt and how we approach managing tech debt at scale. So, how do we manage tech debt? Well, the way that we manage tech debt at ANZ Plus has changed and evolved over time as the team has grown and matured. And rather than just skipping straight to the answer and telling you what we do now, I would like to take you on the journey that we have been on in our management of tech debt. And that journey begins with culture. And before I tell you how you use culture to manage tech debt, I would like to situate us in time and space to the beginning of 2022. So I joined the team in the later half of 2022, which is why I'm using the beginning of 2022 as a sort of point in time. At the start of 2022, the team and the code base was much smaller than it is today. We had less than 30 engineers, less than 200,000 lines of code, and the application had never been publicly released before. So during this time, tech debt was mainly managed through the culture of the team and sort of informal practices that grew out of that culture. So what did that look like? Well, one of the key foundational things that still to this day drives our management of tech debt is our zero tech debt principle, which is the idea that we should always be driving our tech debt towards zero. Potentially an unattainable goal, but it's an aspiration to strive towards. Within the team, based on this zero tech debt principle, we would build a shared understanding of what good code was, what we wanted the architecture to be, and we would document that and build a shared understanding amongst everybody based on that documentation. And then based on that understanding of what the tech debt is, or what we wanted to change about the code base, we would do these sort of collaborative informal migrations that we called sweepy broomies, where we would just say, okay, we're changing from this framework to this framework. All right, for a week or 2 weeks, everybody just focus around this and let's get it done. That matched really well with our zero tech debt principle, because obviously if you just get it done, there's no tech debt to hang around and deal with later. But over the course of 2022, the context that the team was operating in changed quite a bit. So looking at the beginning of 2023, the team had more than doubled in size and was now more than 55 Android engineers. And the code base was rapidly scaling too. We hit over 250,000 lines of code, and we were seeing more lines of code being added every week. And beyond that, the app had now been released and was continuing to be released twice a week to the Play Store, which changed the way that we were, our product owners and things were wanting to drive delivery of features into the application. With that change in context, we started to see some cracks appearing with this purely culture-based approach to tech debt management. More code meant more difficulty doing those big informal collaborative migrations. More people meant more people to keep up to date with what we understood tech debt to be or to organize in those big migrations. More changes to the way that we wanted to approach things meant more documentation that those more people needed to stay across. And because we were released to the public, we had more delivery pressure, which meant less time to focus on those big migrations and to understand where the tech debt was. So we started to look at how we could manage tech debt at scale in a little bit of a different way, beyond just culture. And in particular, we started looking at architecture tests. Now, architecture tests, for those who are not familiar, are essentially a way to define architectural rules as unit tests in your project. These can be automatically verified when you run your tests, just like any other tests, run them on CI, and make sure that everybody is writing code that matches the architectural rules you have set up for the project. This is a nice step above just simply documenting things, because instead of having documentation that people need to read and understand, they actually, if they do the wrong thing, they get that feedback and it says, this test has failed. You actually need to understand why it's failed and resolve that problem. So a quick example here. During my time at ANZ Plus, we made a little bit of a change to our view model architecture, and we decided that for all of our view models, we wanted them to expose only a single state flow. So the idea being that rather than having two separate state flows for two different properties like name and age, you should actually put those together into a single data class that represents the state for that view model and expose only the one state flow. So this code that we have here would fail that rule, right? We wrote up our architecture test, got that ready to open into a PR, but then you can't actually merge that PR because you have potentially hundreds of view models that are failing this rule. So we, the whole point of going down this path was that we didn't have time to do those big migrations all at once. So we need a way to skip or ignore certain rules. And so the way that we did that was by adding these annotations that we call architecture exceptions. And so in this case, we would add the view model exposes multiple state flows to our example code here. And that would allow this piece of code to pass the test. So we add the rule, we add the annotation to everywhere where the rule is being violated. And what that gives us is a really easy way to identify tech debt that is quite searchable and easily understandable in the code base. If you open a file and you see a couple different architecture and exception annotations in that file, you know that, hey, perhaps you should spend a little bit of time uplifting this file while you're working in that area. Or perhaps if you're looking around to find examples of the way that something has been done, and you open a file and it's got architecture exceptions in it, maybe that's not the file that you should pick for your example. You shouldn't copy paste that code perhaps. And so by adding these architecture exceptions and raising the visibility of the violations to our architectural rules, we started to see the total number of architecture exceptions start trending down in the code base, which is obviously what we wanted. But despite the total trending down, we were still seeing new code being added to the code base that had architecture exception annotations on them. And in some cases, this was valid. For example, if I was writing some new code that itself depended on some legacy code that had a sort of infectious architecture exception, perhaps I really did, for now, need that architecture exception. But in some cases, the architecture exceptions were being added due to delivery pressure, the idea that things just needed to get out the door, or being added because of a lack of understanding on how to actually solve a particular violation. So we decided we wanted to further raise the visibility of these architecture exceptions. And the way we decided to do that was by introducing some weekly reporting on our architecture exceptions. The idea here is quite simple. We already had a meeting every Friday where we got together as a whole team and talked about what was going on in the code base and in the wider Android ecosystem. And we would create a weekly report of architecture exceptions in the code base. And then at our Friday catch-up, we'd spend a couple of minutes reviewing that report and seeing what's changed. The report itself, nothing fancy. We built a Gradle task that did something like this. There's a bit of example code that sort of gives you an idea of how that Gradle task works. But all that task did was look at files, read all of the text in the files, match a regex that matched the architecture exception annotations, and then count how many times there were different architecture exceptions in all of the files in the project. Then, using our existing CI infrastructure, GitHub Actions, we would run that task on a schedule once a week on Friday mornings before our big catch-up, which would produce some markdown that had all of those counts in them. And then that would be the report we would review. And the output of that report looks something like this, which might be a little bit small for those in the back to see, but there's a table on the left-hand side. We have a list of all of the modules in the project. On the right-hand side, we have a count of the exceptions, architecture exceptions for those modules, along with a delta of how that count has changed over the last week. So the feature foo module has removed 2 architecture exceptions this week. Awesome work. And then underneath, we had some more detailed information about links to files where exceptions had been added and removed. Now, this report was pretty well received by the team, and the team really enjoyed being able to see, week on week how things were changing with the architecture exceptions. And because of that, we quickly expanded our weekly reporting to include other areas, such as unit test coverage, build warnings, deprecations, and additional specific reports to track the progress of our large migrations, such as our modularization migration, compose migration, and our navigation system migration. However, as we began to add more reports, we started sort of suffering from success a little bit. With this detailed information split across 6, 7, 8 or more reports, there was just too much information to really parse it all and understand at once. And as you might have seen on the example report there, you can kind of imagine there were some unfair comparisons that got made. For example, if there's a module with 20,000 lines of code and it has 10 architecture exceptions, that's probably pretty good on average. However, if you have a module with 2,000 lines of code and that module has 10 architecture exceptions, that's actually probably pretty bad. And because of this sort of unfair comparisons between modules and having too much information across all these different reports, that led to some unclear priorities. So for example, you look at the architecture exception report and the module you own has architecture exceptions, but you also don't have great code coverage and you've got some build warnings and you're a little bit behind on the compose migration. Which one is the next thing to focus on? So we looked at tackling this issue by replacing our weekly review of reports with some weekly scorecards. So the idea here was quite simple. We'd run all the reports on Friday, just as we had been, gather the data from all of the different reports, collect those together, give each module a score across each of the different reporting categories. So a score for build warnings, a score for deprecations, a score for test coverage. Then output another markdown report that sort of based on those scores would act as a summary of all of those other reports and give us a really easily glanceable way of evaluating the health of a particular piece of code or a particular module in the code base. And so that looked something like this. We used an A to F grading system, and this is a picture of a scorecard from I think mid-2023 or early 2024 perhaps. And you can see, I've redacted the module names, but there's the different categories across the top and different scores, along with a little bit of an indication as well about the size of the module and perhaps the importance of the code health there compared to other modules owned by the same team. Now, there's a bit of interesting depth here that I would like to touch on. So obviously, this allows us to do relative comparisons, taking that example from before, 20,000 lines of code and 10 architecture exceptions. Well, we can scale those scores based on the lines of code and call that a B. But for the module with 2,000 lines of code and 10 architecture exceptions, after scaling that metric, we can call that an F, perhaps. Now, using these grades rather than scores also allows us to adjust that over time. So while 5 lint warnings will always be 5 lint warnings, what we think is a good number of lint warnings to have per module might change over time. So that 5 lint warnings might be an A today, but in 6 months' time or a year's time, that might be a D grade, representing us shifting and increasing what we think good looks like for a particular module or piece of code. And adjusting the way that we calculate grades over time also allows us to provide focus and help with some of that prioritization. For example, in the early days of our navigation system migration, we didn't want people to jump on that and do it all at once. There were more important things to focus on, but we did want teams to start playing around with it. So what we did is we set the minimum grade to a C. So there was impossible to get a D or an F. And all you needed to do to get a B grade was to use that the new navigation system in one file in your module. So just have a little play around with it and your module gets a B. As time went on and as we approached the end of the navigation migration, the minimum for a B stepped up until the point where it was 80 or 90% of the module had to be migrated to be considered a B. And finally, these A, B, C grades are a lot easier to communicate with non-technical stakeholders. For example, if you go to a stakeholder and you're owning that big module there and you've got lots of Fs, you can kind of use that as a way to talk about the health of your code base. And in particular, say you have 50 deprecations. If you went to your product owner and said, I have 50 deprecations, we need some time to resolve that, the first question is going to be, well, 50, how many do the other teams have? How is that good? Is that bad? Obviously you want 0, but there needs to be some balance perhaps. Whereas if you can go and you can say, we have a D in our metric for deprecations, makes it a little bit clearer what that sort of relatively means within the code base. But despite these big advantages of this metric scorecard approach and reviewing these weekly, this was not quite a perfect solution for us. This report only ran once a week. We didn't have any history to be able to go back and track how things had changed over time. And being outputted into a Markdown report meant that we got the one fixed view that was in the Markdown report and only that view. There was no aggregation or filtering or sorting. And so in attempting to solve these issues, we reached the final step in the journey, which is where we are today, which is what I will call continuous reporting. And the continuous reporting step was a clear next step for us. And also quite a simple idea, really. Instead of producing a report once a week, we would run the metrics on every commit to main, take that data, push that data into BigQuery, and then use Looker Studio to create dashboards that would get updated every time the data was updated. This gives us the obvious advantage that the reports are always up to date, because every time you commit to main, that data is getting updated, those dashboards are getting updated. But by having the data in BigQuery and using Looker Studio for the dashboarding, we have been able to have much more flexibility in the way that we present and understand the data. So, for example, it's pretty simple to get this sort of view, which is essentially the same as the previous Markdown report. It's a per module breakdown of the scores for the modules. You know, there's some nice highlighting and stuff. But in particular, I've been able to sort by the lines of code count for each module, which is something that would just not be possible in that Markdown report. On top of that, we could then get a more high-level view across the project. Our squads are organized in groups together of teams who are working on similar functionality in what we call value streams. So we're able to get a value stream view across the code base. So a high-level view that product management or senior engineering managers might be able to look at and understand how 3 or 4 teams underneath them are dealing with code health. But this is not the view we look at the most. The view that we look at the most is this view. And this is our squad view. So for those of you who came along to Luke's talk about modularization earlier in the day, you'd know that we have sort of on average 5 modules owned per squad. And so what this does is takes all the modules owned by a squad, gets an average score of that, and this is sort of the Goldilocks zone of us. And this is the report that on a Friday, we open up, we look at, and we call out anything interesting that we see. So here we can see that in the top row, it's pretty cool. This last week, we have seen that top team increase their unit coverage up to 80%, highlighted in blue there, which means a good change. They've increased that grade to a B, which has increased their average overall to a B. That's wicked. We can also see there is one team whose unit test coverage has gone down, but actually they've gone down to an 87% coverage, and 87% makes them tied for first place, and they're already getting an A, so that's cool. Like, that's not a problem at all. That's nothing to worry about. And we've got some other negative changes here. You can notice that there are some build warnings and deprecations that those counts have increased, which is a negative change and is highlighted in red, but actually that's not a problem. These teams have recently been upgrading some versions of libraries which have introduced new build warnings and deprecations, and these teams know about it and understand that they need to deal with that change. The important thing here that I want to talk about is telling stories about these metrics. The negative change is not the problem, or is not a problem. If you see metrics go down and you can explain why they're going down, or talk about when you're going to resolve those. For example, we're running towards a deadline. We can't deal with these deprecations now, but we're going to have some space in 2 months to deal with that. And so we're accepting this tech debt that we're taking on, and we have a plan to resolve it. That's excellent. But if you see some negative changes and you can't explain why you're seeing those negative changes, that's just a really good signal for you to go and look at the code and really understand what is going on and what is changing. Now, this is really just a fancy aggregated view of that Markdown report, but having the data in BigQuery and Looker Studio has let us do reports like this over time for some of our bigger migrations. And this is the real Material 3 migration dashboard that we have. So you can see at the beginning of this year, we had more files left. That orange line is Material 3 files that need migrating, and the blue line is the files that have been successfully migrated. You can see how that has changed over time, and we can track how we are, going in terms of progress. Are we going to hit the deadline that we are setting for ourselves? And below that, we can see a team-based view showing the teams that still have things that need migrating. And in fact, you can see there that there's one team that looks about 15 or 20% done, and all of the other teams look like they're more than 90% done. It's maybe something we should look at and understand. Well, in this case, actually, we do know what's going on here. That team is our platform services team who don't really own much UI. And so those unmigrated files, it's like 5 or 6 files that need migrating. And they're the sister team of the team that's running the migration. And what is likely going to happen is that once all the feature teams have been helped to finishing that migration, the platform team will be able to knock out those couple of files very quickly and be done. That's what I'm talking about in terms of being able to tell a story about the code base and understand what's going on with tech debt. So if that wasn't the services team, if that was a feature team, perhaps this would be an opportunity for us to reach out to them, understand what support they needed in achieving the deadline. Did they need help? Did they have a plan that they hadn't communicated with the rest of us? And being able to see this view lets us know that, if we're seeing that we're not going to hit a deadline, we know that we're not going to hit that deadline well in advance, and we can adjust our approach or provide additional support to the teams or change the deadline if it really is just unrealistic based on what we're seeing. So this has had quite a big impact, being able to measure and understand our tech debt, manage our tech debt in this way. Big impact for the team in the last year and a half since we've had the data in Looker Studio. And I want to take a moment to brag and talk about how this has impacted the code base in ANZ Plus. So since we put that data into Looker Studio and started using this to manage our tech debt, we have removed over 1,000 architecture exceptions from the code base, migrated over 600 files to Material 3, migrated 250 different screens to Enro, our new navigation framework, removed over 1,200 deprecations from the code base, completed our modularization migration, and we have addressed all of this tech debt while still adding 250,000 lines of new production code, which, if you have a good memory, you will remember is the size of the entire code base at the beginning of 2023. So being able to see and understand these metrics in this way, having that visibility, has been super powerful for us to be able to address tech debt while still moving at pace. So I would like to sort of close out by providing a little bit of advice for teams who are interested in this. Number one, culture comes first. Our zero tech debt principle is still a foundational part of how we think about tech debt and drive it. But beyond that, it's really important to have a healthy culture and psychological safety before you go measuring and raising the visibility of metrics like this. You need the teams who are getting Ds and Fs to be curious and not feel blamed or under attack or under pressure. And so that comes from building a healthy team culture. From there, start measuring. Just like start measuring anything. Build warnings, deprecations. Measure it in quick, hacky ways using regexes and file searches and stuff, but just measure something. Once you have those measurements, raise the visibility of those measurements, share those with the team, and get curious. Find the story behind those measurements, behind those metrics, and understand what they mean and why they're changing. And then sort of loop around, add more, evolve that, find the more complex story. But above all else, the big piece of advice I have for anybody here, particularly senior or staff plus level engineers, is seriously do this. This has been really revolutionary to the way that we manage and understand tech debt at ANZ Plus. And my job would be completely different if we didn't have this. Much more difficult and completely different if we didn't have this functionality. So please, seriously, think about this, do that. If you are interested in the zero tech debt principle, Luke gave a talk 2 years ago about it, and I spoke about architecture testing 2 years ago as well, and the recordings for those talks are there. And I think we may not have any time for questions because I ran over. Okay. We maybe have time for one question, I heard.
One question.
But I think we're on a break, so if you want to, after this, we're on afternoon tea, so if you want to talk to me, please come up. Oh, we have ice cream.
Yeah, hi.
Grab an ice cream and come chat.
Thanks for the talk. Great talk. I was wondering if the scorecards were ever used to, I guess, measure performance of teams, or basically, I know you kind of touched on it on culture and not to kind of point fingers and stuff like that, but humans always tend to play the blame game. So I'm just wondering if that ever happened to you guys.
No, that's never happened to us. I think part of the important thing there is that this entire thing was driven by engineering, wanting to understand our code base better. And if this was to ever be used about that, like in that way, I think myself and all of the engineering management structure we have would be like quite against that. This is for us to be curious about. Some of our best performing teams have some of the worst grades because they're working in like the oldest parts of the code base that have the most room for tech debt to accumulate, and just simply have a larger historical base of code. And so we know that they're going to take longer to get things done. Yeah, it's not about punishing failures. It's about celebrating successes and understanding how to move forward together as a whole team towards doing the best we can. Okay, thank you.